All right, guys, we are on to the 4.2 notes, reflections. So here we go. Let's use GeoGebra. 1, 5, 3, 2, 4, 3. Let's plot this triangle. So, go down to more. Come on, watch out. More. Polygon. 1, 5. 3, 2, 4, 3. 1, 5. Oh, man, this thing crazy. 1, 5, 3, 2, and 4, 3. There we go. And then we want to reflect this in the line y equals -1. So, to graph the line y equals -1, first go to line. And then we've got y equals -1 is going to be a horizontal line. So all you need is 2 points along that line, and it'll represent it for you. So now, we want to reflect this triangle about this line. So that's where we go back to our transform section. Yesterday, or last section, we did translate by vector. Now we're going to reflect. So reflection is also a transformation. So once you highlight that, click on the triangle, and then the line you want to reflect, and there you go. And again, if you want to take a good look at it, go back and move my graph paper so you can see what's happening here. And let's see, B to B prime, as you can see, the distance from B to the line of reflection will be the same as the distance from B prime to the line of reflection. The X values do not change if you revolve or if you reflect about a horizontal line. All right. So that's what we're looking at. And then on a quiz, of course, our new values here of A prime, B prime, C prime would be the coordinates that you would answer, how you'd answer that on the quiz. All right, so technically a reflection, here it is by definition, is a transformation that uses a line like a mirror, yes, to reflect a figure. And of course, the mirror line is called the line of reflection. All right, in example 1, they're showing you what would happen if the line of reflection, in this case it's vertical, x equals 3, all right, what it would look like if your triangle was actually inside of it, essentially. If the line was passing through it, you could overlap on yourself, no big deal. Similarly, in this one, y equals 1 is actually touching the point C because it's 2, 1. And so if you reflect on that, then your new image can actually still just touch your old image. It's allowed to do that as well. All right, monitoring progress. Let's take this triangle from example 1. So we're going to use these coordinates, and we're going to have some fun on GeoGebra. So let's do it here. I'm going to clean up my GeoGebra, go to a new, clear all, don't save it. All right, so my triangle was 1, 3, 5, 2, 2, 1. So let's plot it. 1, 3, 5, 2, 2, 1. All right, now this is telling me to, let's see, let's do this one first. X equals 4. So let's plot the line. Plot the line x equals 4. So here we go. Vertical line passing through where all the points on it are, all the x values are 4. And then I would go to transform, click the triangle, click the line. And so there's an example where it's going to cross over onto itself. And again, all the points in B prime, A prime, C prime are the same distance away from the line as the points A, B, and C were. Next, let's take this triangle and let's revolve it, or I'm sorry, reflect it in the given line of x equals -3 this time. So x equals -3. Let's plot that. So x equals -3 is the vertical line at -3. And then we go back to transform. Our given triangle is here. Reflect it. Oh yeah, so it ends up over there. So as you can see, A is 1, 2, 3, 4 away from the line. A prime is 4 away from the line perpendicularly. Next, let's do some horizontal lines. So y equals 2. Y equals 2. Go back to line. Y equals 2 is up here. Back to transformers. Take the triangle, reflect it across the line y equals 2. There you go. That one's kind of neat looking. And the last one now, let's do y equals -1. So back to our little handy dandy GeoGebra. Y equals -1 down here. Go back to transform. Tough to see the original triangle now. Just going to shoot it down there into the 4th quadrant. All right, so each of these images would be your answer on a quiz if I asked you to reflect about a line. All right, now example 2 is talking about the line y equals x. So not only will we have horizontal and vertical lines to reflect across, we're going to also look at the line y equals x. So now we're taking a segment. So first off, go back to your GeoGebra, clear things up. All right, now it wants us to graph the segment -1, 2, 1, 2. So let's do it. Let's go to segment. Under the line section, we see segment -1, 2, 1, 2. Boom. So there's our segment. And now we want to reflect that in the line y equals x. So what does the line y equals x look like? Well, y equals x is going to pass through the origin because there's no b value, right? mx plus b. And the slope is 1. So the line y equals x is a diagonal line through the origin. All the points are the same. 2, 2, 3, 3, -5, -5. The y's and x's are equal. So no big deal, right? We can reflect in any line. So go back, transform, reflect about a line. Click on the segment, click on the line, and now your segment is reflected. So the cool thing about reflecting in the line y equals x is look what happens to your points. B is at 1, 2. B prime is at 2, 1. A is at -1, 2. A prime is at 2, -1. So essentially your x and y values just flip-flop whenever you reflect in the line y equals x. All right, friends, this is the general rule. Back in my day, we didn't have fancy GeoGebra. So we had to do this by hand, and we had a set of rules that we used. And you can still do that. That's why I included these here, your coordinate rules for reflections. The one we just analyzed was this one, y equals x, it just flips flops. If it's a, b to start, it's BA when you plot it. And you feel free to do that. And but you don't have to. Obviously, GeoGebra will do it for you. Next is the line y equals -x. So let's take a look at what would happen when we reflect in the line y equals -x. So let's take this same segment and let's see, the line y equals -x, let's put the line in, is just going downhill through the origin at the slope of -1. So these are the two other lines other than horizontal and vertical that you'll have to reflect in. And transform. Now click on the segment. And now the line y equals -x, and you can see when you reflect across this line, all right, now what happens? A, which was -1, 2, becomes A prime, which is -2, +1. So you flip-flop X and Y, and you put negatives in, or you negate it. If it's negative, make it positive. If it's positive, make it negative. So B went from 1, 2 to -2, -1. So that's reflections in the line y equals x, my friends. All right, let's take a look now at a glide reflection. First off, reflections are rigid motions, which we talked about in 4.1. A rigid motion is an isometry, which means you do not change the size or shape, you're just moving it to a new location. So reflection does that as well. It preserves our size and shape. Well, important study tip for a glide reflection. First off, a glide reflection is a transformation involving a translation followed by a reflection. So you're going to translate and then reflect. That's all a glide reflection is. Cool thing is that this little note, the line of reflection has to be parallel to the direction of the translation. So for instance, in this picture here, you start out with PQ, this segment, and we slide it in this direction. So we'd have a vector going up like this, and that vector is parallel to the line you're going to reflect in. So we slide it up here, then we flip it over here. So as long as the line is parallel to the vector, then it's a glide reflection. So let's take a look at this glide reflection. And again, you can use GeoGebra for any of these things. It wants us to translate. So this would be the vector -12, 0 in component form. Slide it 12 to the left and then nothing up or down. And then reflect it in the x-axis. All right, so it's going to look like this. Start out here, glide it or slide it 12 units to the left, and then reflect it in the x-axis, which is the line y equals 0. So since our glide and our flip are parallel, this constitutes a glide reflection. All right, the monitor progress. In example 4, ABC is translated 4 units down, then reflected. So no big deal here. This is saying, hey, translate it down here, and then reflect it in the y-axis, which you could do that, no problems. And example 4, describe a glide reflection. So what would happen is you would translate it. In example 4, describe a glide reflection from A double prime, B double prime, C double prime, backwards. So in this case, we would glide it backwards and then reflect it in the line. So no hurries, no worries. And let me see, having trouble with my pen here, guys. I'll just type it. There you go. All right. Last concept today. Come on, pen. Ah, there we go, good. Okay. A figure in the plane is a line of symmetry. So symmetry, well, it looks the same on both sides, right? Well, for us, it's in this reflection section because whenever you can map a figure onto itself by the reflection, that constitutes a line of symmetry. So it involves a reflection. And so let's take a look. A hexagon, I could reflect this way or this way. And when you did it, it would look exactly the same when you were done. Now a regular hexagon, you see you got 1, 2, 3, 4, 5, 6 different lines of symmetry. So 2 on this one. And now in part C, though, you can see that there would be no way we could go vertically that would make this look the same when you spun it, or when you flipped it. So therefore, it only has one going horizontally. All right, pause the video and see what you come up with for the monitor progress here. All right, welcome back. All right, the rectangle, the pentagon, and the triangles. So 2, 5, 1. Let's see. So there's 2 for the rectangle, and you might think you might be able to split it diagonally, but think about that. If you were to split it this way and reflect it, this point, for instance, this corner, it would be the same distance away, so it's down there somewhere. So it's not, the figure is not going to look the same. If I spun that, it would look like that, and that's no longer mapped onto itself. So we only have 2. Of course here, we have the 5, and we only have the vertical one here. There's no way we could split this horizontally. An isosceles triangle. All right, drawing a hexagon. You can get a little something like that, right? You get a little freaky with that one. All right, guys, so that's reflections. Feel free to watch as much as you want to figure all this stuff out. I love you all. Peace.